All right, picture this. You're running this massive, fully automated publishing network. You check your dashboards, and everything is completely green. The throughput graphs look perfectly healthy, and your error alarms, dead silent. But underneath that shiny, perfect surface, the entire system is quietly, slowly collapsing. Welcome to today's Explainer, where we are going to unpack a truly fascinating case study by systems designer Thorsten Meyer. We're looking at a 474-site publishing network that literally strangled itself, all while doing exactly what it was programmed to do.
So that perfect illusion of a healthy system, it completely shattered during a 28-day audit. Now, the total volume of articles being published was perfectly on target, but when the engineers actually looked at where that content was going, they found a jaw-dropping imbalance. A massive 80% of all posts were landing in the exact same place, specifically just 38 sites. The system had, essentially, decided to exclusively feed its own tiny group of favorites.
And honestly, that imbalance reveals a pretty dark reality about what was happening under the hood. While 80% of the output is being crammed onto just 8% of the sites, the rest of the network is literally starving. 53% of the entire catalog, that is 249 different sites, went completely dark. They received absolutely zero posts in an almost month-long window, and again, all of this happened without a single error firing.
Okay, to really get how a massive failure like this stays completely invisible, we need to meet our cast of characters. The network runs on two distinctly decoupled systems, and they have a very strict division of labor. First up, we have Stenvrik. This is the news intelligence layer. You can think of it as the supply. It ingests feeds, scores stories, and decides what's actually worth covering. Second, we have Dojo Claw. This is the AI content engine and placement layer. It takes the story from Stenvrik, rewrites it, and decides exactly where it should land in the network. So Stenvrik judges editorial worth, and Dojo Claw judges network placement. Keep this strict separation in mind because it is absolutely crucial to solving our mystery a bit later.
So what exactly was Dojo Claw up to? Well, it turns out it had picked 4 absolute favorites, and they were all technology and AI sites. These 4 sites were absorbing more than 200 articles a week. Guys, that's roughly 30 articles a day per site. For an independent publishing magazine, dropping 30 near-simultaneous articles a day is incredibly dangerous. It puts them at massive risk of looking like pure spam to search engines, which is basically a death sentence. The wildest part of all this? Every single algorithmic decision Dojo Claw made to place an article there was technically correct based on topic matching. But when you aggregate all those correct individual decisions, you get a slow-motion disaster.
Now, you might be wondering, how did Dojo Claw get stuck in this loop in the first place? The diagnosis revealed a really sneaky placement trap called within-topic concentration. Basically, the AI matcher was looking for a home for a text story, right? So naturally, it surfaces broad text sites. Then the rotation logic shuffles the candidates to make sure things are fair. But here's the catch. It only shuffled within that already matched tech pool. So if you were a dormant, empty site outside of the tech category, there was no way you could ever even enter the pool to get a turn. The algorithm was only being fair among the already chosen.
It's super tempting to just point the finger at Dojo Claw's routing algorithm and say, case closed, right? But the data revealed a second, completely different suspect, Stenvrik. The supply layer was pumping in feeds that were 53% tech and AI content, but only 13% of the actual network sites belonged in that category. Meanwhile, you had 103 home sites and 68 health sites sitting completely dark. And it wasn't because of a routing bug, but because there was almost literally nothing on topic flowing in for them to actually publish.
And this right here brings us to a huge aha moment for anyone designing complex architectures. This wasn't just one bug. It was a twin problem wearing a single symptom. You simply cannot spread content that doesn't exist. And on the flip side, you absolutely cannot fix a massive supply mismatch with a smarter routing algorithm. Fixing this required 2 entirely independent solutions.
All right, so how do we fix Dojo Claw? They pulled 3 pretty clever engineering levers. Step 1, a per-site weekly cap of 25 articles. You hit the cap, you drop out of the pool completely. Step 2 is kind of the genius part. Global least recently used ordering. Instead of just looking at recency within a specific topic, the system now looks at network-wide idleness. Sites that haven't published anything at all float straight to the very top, which perfectly sets up Step 3, a built-in starvation floor that guarantees the most ignored sites in the network finally get fed.
But wait, remember our golden rule here? Smarter routing can only redistribute what actually exists. So the investigation shifts back to Stenvrik, the supply layer. They audited the feeds for all those starving categories and found something really insidious: ghost feeds. These were broken RSS feeds returning an HTTP 200 status code, which is the universal web signal for, hey, everything is perfectly fine, but they were delivering absolutely zero actual content items. Stenvrik was essentially holding an empty pipe and fully believing that water was flowing. Those feeds had to be aggressively purged.
Okay, ghosts busted. Now it was time to rebalance the actual raw editorial signal. They deliberately injected fresh, verified supply directly into the system. Every single new feed was fetched live and confirmed to return real, usable items before it was ever accepted. They pumped high-volume sources specifically into home, garden, health, food, and all those other categories that Dojo Claw had been starving. So the feed registry didn't just get bigger, it grew with a highly deliberate tilt to correct that fundamental supply mix.
With the placement finally spreading properly across the network and the supply flowing to the right categories, the system was actually ready to be pushed. Because this newly repaired architecture could handle the load without just collapsing onto a few favorites, they safely raised the daily output ceiling. The scheduler's output jumped from roughly 188 articles a day to about 280. That is a massive 49% increase in throughput. And the best part? This time it was healthy growth, not just spamming the top tier.
Now, how exactly did they boost that throughput without, breaking the whole system again? They used two specific upgrades. First, they expanded the fan-out width from 5 sites per story to 7. Second, they scaled up the quota depth, which is the total volume the system processes, by half. Normally, widening the fan-out like that just spams your favorites even harder. But thanks to Dojo Claw's new caps, the algorithm was physically forced to push those extra slots onto fresh, idle sites way down in the long tail of the network. Raising the ceiling finally worked exactly like they wanted it to.
Oh, and I have to mention this really fascinating, kind of funny engineering artifact they found during the rebuild. Deep inside the code's comments, someone had described an intent to hit roughly 950 articles a day. But because of a weird quirk with the units, the code literally never, ever actually delivered that. It was just an aspirational number that somehow turned into system folklore. It really proves a vital point about engineering discipline, doesn't it? An aspirational number that the system never actually hit is exactly the kind of thing that will totally mislead developers a year down the line. It is always, always better to clearly record what the code actually does rather than what a comment once hoped it would do.
Now, we do need to put an honest little asterisk next to this whole repair operation. The fixes we just walked through, they are strictly behavioral. They shape how future placement unfolds, but they don't magically jump into a time machine and rescue those 249 sites that sat completely dark for a month. A fix you cannot measure? Well, it's really just a hope. Therefore, the single most valuable artifact of this entire exercise was setting up ongoing documented instrumentation, specifically per-site weekly bucket queries. You have to actually watch the tail fill with data to know for sure that your fix is real.
Let's zoom out for a second. This whole invisible collapse and the way they fixed it is basically a masterclass in system architecture. Why was this solvable at all? It's all because of that strict separation between Stenvrik and Dojo Claw. If this network had been built as a monolith, the supply and placement logic would just be a single, tangled mess. The symptoms would blur right where the problem actually lived. But because it was decoupled, the failure was actually legible. You could stand on the Dojo Claw side, look across the boundary at Stenvrik, and clearly see that the demand simply didn't match the supply. Which brings us to a seriously powerful quote from Thorsten Meyer regarding the true purpose of architectural design. He notes, "Good system boundaries don't just organize code, they organize thought." By having a clean line between the editorial judgment of the feeds and the organic distribution across the network, the engineers were able to isolate their thinking. They could test their assumptions independently and apply the correct specific levers to both sides of the equation without making a mess.
It's a total mindset shift, right? It's not just about making the code compile cleanly anymore, it's about making the inevitable failures understandable to the human mind. So I'll leave you with this to ponder as you go back and look at the architecture of your own projects. Are the boundaries in your systems merely organizing your code, or are they actually organizing your thought? Think about it.